We can start then.
Yeah, let's do it.
Welcome everyone to, I guess, the second huge official event of the Center for Transformative Media. The first was last year with the publication of our Journal of Autocosmology, edited by Ashton Arnaldi and Ari Makrodakis. And last night we had Annette Williams and Arisika Razak interrogating the cosmology of the Yoruba religion. And tonight is part two of what we're calling the birth of life and the future of consciousness, which is a symposium that began with a series of conversations, I think initiated by Matt Segall in conversation with scientists, technologists, astrobiologists, all kinds of interesting people in Santa Cruz last year that led to the idea of bringing to CIIS a conversation like this that would bridge ideas about consciousness from East and West across programs, across disciplines, and that made it happen. And here we are tonight for the second night. And tonight we have Matt in conversation with Bruce Dahmer. And this is just an incredible event. You are really in for a treat. I'm going to read the bios of our two panelists so you understand what's going on here. Matt Segall, PhD, is Assistant Professor in the Philosophy, Cosmology, and Consciousness program at CIIS, where he teaches courses on German idealism and Alfred North Whitehead's process philosophy. He's published on a wide range of topics, including metaphysics, the philosophy of science, the evolution of religion, and psychedelics. He blogs regularly at footnotestoplato.com and tweets more than he should, he feels, at Thou Art That. His current obsessions include the panpsychist turn in contemporary philosophy of mind and its implications for the scientific study of the origins of life and consciousness. And Dr. Bruce Dahmer is a scientist, designer, and speaker. He holds a research position at the University of California at Santa Cruz, where he collaborates and tests a new hypothesis for the origin of life on Earth. He has also engaged in 20 years of spacecraft and mission design with NASA and others for the purpose of finding a way to extend life into the cosmos. He's on the team at the Luminous Awareness Institute, which engages advanced modalities of healing, providing paths to awakening to conscious self-awareness. Recently, he synthesized he has synthesized these themes together in a unified view of origins, evolution, and the rising of a conscious field, which is becoming a coherent OS we can interact with, a kind of God for geeks. Lastly, he's a curator of the counterculture, hosting the extant archives of Dr. Timothy Leary and Terence McKenna, as well as a century of historical technology in his Digibarn Computer Museum. You can find his personal website, the Levity Zone podcast, and his personal Patreon, where you can engage him directly at http://www.dahmer.com. And it's such a pleasure for the Center for Transformative Media to be part of this incredible conversation that is about to begin. Thank you.
Thank you, Carolyn. This has been a long time in the making. I mean, Bruce and I met in March, but it took the whole history of the universe for us to be able to arrive in our present form. Congratulations to us. Quite an accomplishment. And as Bruce will tell us, it didn't have to be this way. We may, in fact, be extremely improbable. Our biological forms, the Anthropocene, might be the most improbable thing that one could imagine given the initial conditions that gave rise to the universe. But here we are. Bruce and I met somewhat serendipitously at on a panel that Carolyn was also on, and Ashton was there, and we were down in Boulder Creek talking to some artists about consciousness and technology, and Bruce started talking about his hypothesis for the origins of life. And as a philosopher, I'm very interested in these sorts of questions, and my mind continues to be blown as I study the research that Bruce and his colleagues are doing. So I'm really excited for him to share that with you and to be in dialogue this evening. So here's how it's going to go. I'm going to give a very brief history of this question of the study of life and the human understanding of life from the perspective of a natural philosopher. That'll probably take about 15 minutes. Bruce is then going to share his research with us, and then we will engage in some conversation, and then we'll open it up for discussion and see what we can figure out. These are deep questions. So those of you who know me know that I study the thought of Alfred North Whitehead. There he is. He was a 20th century mathematician, physicist, and philosopher who developed a cosmological scheme that he felt did justice to the revolutions in science which took place in physics with relativity and quantum theory, with the birth of complexity theory, which wasn't yet called that in the early 1920s and 30s when he was writing. But those ideas were beginning to germinate, and he participated in that. He's an evolutionary thinker as well. And he articulated a comprehensive philosophical scheme where, for him, what philosophy is attempting is a generic account of the nature of existence that is generic enough or general enough that all the special sciences and all the specific domains that they deal in and the abstractions that they develop to describe the domains that they deal in, so that all of those special sciences can hang together as part of a comprehensive picture of the universe. And not just the sciences. Whitehead also thought we had to make room for spirituality. We had to make room for art. We had to make room for our common sense experience as conscious beings who more or less think that we're agents acting in the world, making decisions, right? He wanted to develop a way of talking about all of that. And for Whitehead, philosophy is not just a specialist study. It's not just something you do in the ivory towers of academia, right? He says, our philosophic outlook is the very foundation of our thought and of our life, and the sort of ideas we attend to, the sort of ideas which we push into the negligible background, govern our hopes, our fears, our control of behavior. As we think, we live, right? Ideas are not just abstractions for Whitehead. They have real power in the world. They shape the type of civilization that we bring forth. So when we look at the history of the human understanding of life, if we go back to primal indigenous consciousness, thousands and thousands of years ago, really tens of thousands, even hundreds of thousands of years ago, we've been anatomically human. And for the vast majority of that history, what anthropologists have called animism was the general outlook. Now, animism was originally coined by 19th century anthropologists and as a kind of pejorative description of primitive people who projected their own sense of their society and their consciousness onto the rest of the natural world. I would not use this term animism in a pejorative sense. I think these people had a more participatory mode of consciousness. They weren't as differentiated from the surrounding environment as modern Western individuals are. They were more porous to the energies of the heavens and of the earth and the animal and plant kingdom, and thought that the stars, the plants, the animals were their ancestors, and they lived in communion with the universe. And contemporary philosophers would refer to this as panpsychism. So this was the basic orientation of human beings for tens of thousands, if not hundreds of thousands of years. And so the German philosopher Hans Jonas says that to the extent that life is accepted as the primary state of things in this animistic worldview, death looms as the disturbing mystery. Hence, the problem of death is probably the first to deserve the name in the history of thought. So in other words, these primal peoples didn't ask, what is life? Life was obvious. It's everywhere. The question was, well, what is death? And you might say that all of human culture and religion is a response to that question. What happens when we die? If this whole universe, it's in motion, it's animated, and yet we die. People's bodies decompose. They seem to disappear from this world. There's all sorts of different cultural, religious, spiritual responses to the fact of death, right? So what is death was the problem for these primal people, not what is life. Life, well, so this view even permeates most of Western philosophy as well. Plato wrote one of his dialogues called the Timaeus, which in Europe and in the Islamic world for almost 2,000 years was the dominant cosmological outlook that framed human speculation on the nature of the universe. And for Plato, the universe is ensouled because the ancient Greek imagination thought that soul and motion were intrinsically linked. We see the heavens above spiraling, the planets moving through, the fixed constellations, it's all in motion. And for the Greeks, motion meant soul. Motion meant life. So the whole universe is a living organism in the Platonic view. And this held all the way through the Renaissance. It was only challenged with the scientific revolution in the 17th century, when a new form of thought that wielded the tools of mathematics and geometry to study the natural world. This is Isaac Newton. Other big names are like Galileo and René Descartes. And this was a tremendous shift. It didn't happen all at once. We talk about the scientific revolution as if people were in the streets saying, the sun's at the center. Barely anyone was participating in this. You know, there's a few people writing letters. We call it a revolution, but it's a very slow-moving revolution. But so all of a sudden, there's a new picture of matter emerging that Descartes formalizes. Matter is mere extension, and it can be measured with geometry and a coordinate grid. Descartes had a view of mind, too, as, well, not matter. It's not extended. It's totally separate from matter. And so the animistic universe, where there was no separation between mind and matter, there was a sense of an interfusion of mind and matter, Descartes totally revolutionizes that picture. Galileo, who started to lay down some of these principles of physical science, bifurcated nature into primary and secondary qualities, right? You're probably somewhat familiar with this story, right? I won't dwell on this, but for Galileo, the primary qualities of nature have to do with the things that can be quantified and measured, right? Mass, dimensionality. The secondary qualities have to do with things that are qualitative. They can't be measured in the same way. And for Galileo, he says these are all the things that the organism adds, projects onto nature. For science to advance, modern science to advance using the tools of mathematics, it had to bracket all this qualitative stuff. Life, consciousness, put that to the side. Galileo wasn't saying it's not real. He just wanted to put it to the side. Let's see what we can measure. And that research project was tremendously successful in its own terms. Newton, you know, formalizes our understanding of gravitation, and you know, Europe thought that all of the universe could be described in terms of these mathematical, mechanistic principles. Now, the question then becomes, well, how does life fit into this picture? This is Immanuel Kant. He was writing at the close of the 18th century, late 1700s. And he's inheriting this new Newtonian worldview of a mechanistic universe. And he's starting to get a little worried about what's going to happen to human consciousness and our sense of morality, our sense of freedom, if this mechanistic worldview continues to encroach upon human life. Because if all of nature is a machine and we're part of nature, and our bodies certainly are, then how can we still think of ourselves as free? So what Kant does is I call this the Kantian compromise. He is a champion of the new scientific method, but in order to protect the human soul from reduction to some kind of mechanism, he says, wait a minute, let's take a step back and ask, what is scientific knowledge really? For Kant, scientific knowledge becomes the laws of nature, become the laws of human understanding. We only know nature as it appears to us. Kant says that he was forced to limit knowledge in order to leave room for human freedom. So the human mind is, in a sense, this is how Kant describes it, the human mind is moved back to the center of the universe as the source of the laws, the categories, causality, everything that science thought, that Newton thought was in nature. Kant is saying, no, this is really the mind. When we look out in nature, we think we're discovering laws of nature. Kant says we're discovering laws of our own understanding. And space and time are really structures brought forth by our particular sensory organs, right? Now, Kant thought that all of the physical world, as it appears to us, could be explained mechanistically, even though that's only a physical world as it appears to us. Whatever's beyond this realm of appearance, Kant said we can't know anything about it. He called this the supersensible world, or the noumenal world, the realm of things in themselves beyond our experience. He said we couldn't know anything about that, but everything that appears to us, everything that we're consciously aware of, can be explained mechanically, except for living organisms, according to Kant. So in 1790, he writes the Critique of Judgment. It's his last critique. He's already written the Critique of Pure Reason, the Critique of Practical Reason, and then he gets to the Critique of Judgment. He's trying to understand how we judge art to be beautiful or nature to be beautiful. And he also wants to understand how we judge things to be purposeful. And he thinks that when we encounter living organisms, whether a single blade of grass or a human being or a dog or a cheetah, there's purpose being realized in these organisms, Kant thought. And we can't explain that mechanistically. Because for Kant, and he was, I believe, the first one to coin this term self-organization, there's a certain causality operative in living beings that has a kind of circular nature, we might say, where rather than a cause being external to an effect, the cause and the effect sync up. And in a living organism, there's a circular causality, so that an organism is producing the conditions necessary for its own continued existence as itself. It's self-producing, self-organizing. So Kant says, it is certain, it is so certain that we may boldly state that it is absurd to hope that someday another Newton might arise who would explain to us in terms of natural laws how even a mere blade of grass is produced. This is the Newton of the leaf. Kant didn't think we could ever have a mechanistic explanation for life. Now, the sciences of complexity and self-organization have advanced quite a bit. And we're going to hear more about that from Bruce in a minute here. A little interlude here. So even in Kant's day, life was thought to be something that could spontaneously generate out of matter, and that this was sort of happening all the time, right? And French biologist Louis Pasteur did a test, very simple test. He boiled some broth, put it in a beaker, created this curved tube to keep it sterile in there. And as long as he left that curved tube on there, no bacteria could get in there. And so he left it and no life spontaneously emerged. He broke the tube so that the air could get in, bacteria could start to colonize the broth. And so he realized life's not just coming out of matter. There's bacteria in the air, and these organisms then enter into the broth and colonize it. So this really catalyzed a new form of research to try to understand where life came from, because it turned out it wasn't as easy as it just popping up everywhere when you leave the steak to rot or you leave the broth to sit on the stove too long. So now, of course, you may have been thinking, wait a minute, there was a Newton of the leaf, a Newton of the grass blade. That's Charles Darwin, right? I would say no. There may be extensions of Darwin's theory that Bruce will get into that can show how he at least originated the basic idea for what it would take to be a Newton of the grass blade. But for Darwin, his theory of natural selection, it was a theory of speciation. It wasn't a theory of the origin of life. It was a theory of how given self-organizing, self-producing, and reproducing organisms, given that, the theory of natural selection explains speciation, or the change over time, the emergence of new species. Darwin didn't pretend to explain the origin of life. That wasn't his aim. In the final paragraph of The Origin of Species, he actually says, at least in the second and all subsequent editions, he adds this line that if you'll give me one free miracle, in the beginning, the creator breathed life into one or a few original forms, and then the laws of natural selection can explain the diversity of life we see around us. So is Charles Darwin the Newton of the grass blade? I don't think so, but we'll see. We'll see what Bruce has to say about that. So very briefly, I just want to introduce Whitehead's take on all of this. So living through the quantum revolution, living through the relativistic revolution, Einstein's revolution, still, it's only 4 or 5 decades into evolutionary theory really starting to permeate the sciences and the deeper understanding of what evolution means. And so Whitehead's realizing that what physicists used to call mechanism in the Newtonian period before quantum theory, before our understanding of matter was turned inside out and upside down by quantum theory, when biologists would refer to mechanism, they knew what they meant because the physicists knew what it was. But the physicists that Whitehead was talking to, and he was contributing to physical science at the time, there was no way of defining what mechanism even meant anymore, given what quantum theorists were understanding about the non-local entanglement of energy events. So Whitehead says the appeal to mechanism on behalf of biology was in its origin an appeal to the well-attested self-consistent physical concepts as expressing the basis of all natural phenomena. But at present, he was writing in 1925, there is no such system of concepts. So this mechanistic metaphor migrated from physics into biology. Physicists got rid of the metaphor, but biologists held on to it. It's not to say that mechanism isn't a useful abstraction, but it's a metaphor, right? So we have to be careful with our metaphors. Whitehead says the doctrine he is maintaining is that neither physical nature nor life can be understood unless we fuse them together as essential factors in the composition of really real things whose interconnections and individual characters constitute the universe. So Whitehead is, you might say, he's an attenuated animist. He's a panpsychist or pan-experientialist. So some form of very simple experience and aim goes all the way down for Whitehead. Bruce and I we're gonna talk more about this later and understand how to say this, that experience goes all the way down, doesn't mean that when life emerges that something really new doesn't come onto the scene, that, as Bruce would say, a whole new cosmos emerges with life. You can still have that dramatic emergence. Whitehead's just saying, unless we have some form of aim or experience built in, that sort of radical emergence wouldn't be possible. That's Whitehead's point of view. So he says, science is taking on a new aspect, which is neither purely physical nor purely biological. It is becoming the study of organisms. So he wants to generalize our understanding of what an organism is. Biology is the study of the larger organisms. I would say the middle scale organisms, whereas physics is the study of the smaller organisms. So we see a gold atom down there. We see 2 cells in the process of mitosis. We see a supernova explosion. For Whitehead, stars and galaxies are species of organism. Helium and hydrogen atoms are species of organism, just as cells are organisms. He wants to generalize our understanding of what an organism is, Because for Whitehead, evolution isn't just a description of the biosphere and the history of life on Earth. We have to cosmologize our understanding of evolution. The whole universe is a historically unfolding energy event. And when quarks form the first protons, when protons and electrons form the first atoms, that is an event of what biologists would call symbiogenesis. A new species is emerging by the fusion of what had been separate organisms before that. And the history of the universe is full of these emergent events. And to understand what's going on here and now with our living bodies, we have iron atoms in our cells. And there's a great complexity scientist named Benita Roy, and I was listening to an interview with her, and she gave this example of what process thinking, like Whitehead's thinking, forces us to do, is to think temporally. So the iron in our cells, in our hemoglobin that carries oxygen, allows our circulatory system to function, allows us to breathe, it was forged in an exploding star, roughly 6.5 billion years ago. Now, when we think spatially and mechanistically, we say, well, that was way back then, and those atoms traveled a long way. And now, yeah, it's really cool. They're like inside of us now. But to think in a process-oriented way, that star is still exploding. We're on the frothy edge of that exploding star. And the capacity of our organism to breathe in oxygen and for it to be transported through our circulatory system is, in some ways, it's continuous. It's a single energy event. It's a single circuit of activity, right? That star is still exploding. We are that exploding star. And so life here and now is a cosmological achievement. It's not just the miracle of what's happening inside of our skin, right? Life requires the whole history of the universe to be what it is today. So Bruce is going to show us how the origin of life in a similar way was a cosmological event, a geological event, and that for the whole thing to boot itself up, all that context was required, right? So with that, turn it over to Bruce. Buckle your seatbelts. Let me get your PowerPoint going here. Close that one down. Close out of that. Okay. Do you want to switch seats so you can do it, or you'll use your clicker?
I'll use the clicker.
Bruce, do you need the lights?
No.
Or would it be better without them?
I'm still.
How are you guys doing online?
You know, can you still? Yeah, I can. Can you guys
Can they
still?
see
Can the
online?
owls still see us?
Do we
I think
need
they
a
can
little
see
light?
us, yeah.
For the recording, do you want to put the light over here, just so we're still lit a little bit? I'll just put the light over there. And if you move it just a little, see, it lights us a bit. Yeah, there we go. It's not too much on the screen.
What if you pointed it up a little bit?
Up. Well, that's a real Hollywood light. Look at that.
That does a little bit. I think they can still see it.
Yeah.
Right.
Thank you, Matt. So Matt mentioned iron and how important it is for our bodies and our breath. And I want to pass something around for you that will help ground the conversation, because Matt also mentioned geology. And this rock was summarily named precious by the good folks at Weta Workshop who made the Lord of the Rings film when I brought it to Lord of the Rings land in New Zealand. But is full of iron, and you can feel the weight of it, the heft of it. But what's also full of is these little ridges, these little ripples everywhere. And what that is the preservation of 3 billion year old life on Earth. Found in Western Australia about 4 years ago. This is a stromatolite because of the layering. And what this rock represents is a stinky lake shore 3 billion years ago on an Archean, a piece of the Archean plate, or a plate called the Pilbara Craton, which is one of the last little pieces of pavement of the original continents, the first proto-continents. And I'm going to pass this around, and in a sense, you can have contact with this. start here. Pass it to, spend a moment with it, because what you're holding in your hand is your common ancestor. That is your common ancestor of us all, of all other bacteria and plants and animals and worms and, you know, mycelia and everything started with these guys. And these guys were these kind of stinky, and I say they're stinky because they're emitting a lot of gas, basically biofilms, like the plaque on your teeth. But they were covering the earth. They were covering rocky landscapes, shorelines, seashores, anywhere that there could be some liquid water, and for these guys particularly some sunlight to sustain them. So that is your common ancestor, and that's about 3 billion years back. We found evidence for life as far back as 3.5, maybe 3.7. There's sort of isotopic evidence at 4 billion years ago, but the Earth is only itself only about 4.5 billion years old. I'm going to pass you something even older around that will give you a direct sensorial contact with an ancient world. What's in here at the bottom of this little vial is a little ground up bunch of powder. And it's a powder from a meteorite called the Murray meteorite that's older than Earth. It's about almost 4.6 billion years old. It formed about the time that the inner planets were forming. And it fell on the Earth a few decades ago. And this is a little piece of it. What we did was we put it into sort of an acidic buffer, actually more of a chloroform buffer, and then we dried it down. What you can do, just keep the lid on, but you can smell it. And what you're smelling is it has a really great depth to it. This is our ancestral material. So what your hand in your hand is the ancestor, the living ancestor. This is the material that formed the solar system and was falling on the Earth in little ponds I'm going to show you that probably gave rise to us. It was the source material. So it's organic compounds, and you're going to smell what are called polycyclic aromatic hydrocarbons in this. But this has amino acids, nucleobases, has fatty acids to make little fatty vesicles and everything. When you smell it, you're really, your consciousness is contacting the oldest thing that you'll ever touch, feel, sense. And it's quite profound. So as I'm talking, you can kind of just sort of ponder that, experience that, you know, the importance of experience.
So when we play the video, I need to mute that.
Okay.
And then turn the volume up here. So is that what's happening next?
I'm going to do a little bit of an intro.
Great.
And then I'll let you come over and mute.
Okay.
So when I was about 14, I was walking in the hills around my hometown in Kamloops, British Columbia, Canada, which is right in the central sort of grassland area of BC. And I was a super nerdy kid, you know, for the mid-70s, 1976. There were no computers in my town. No one had ever touched a computer in our town. They were sort of vaguely boxy things overseen by a priestly class somewhere. But I was very much into the idea of computing, with the idea of complex systems. And I designed board games. And I did thought experiments since I was about 8 or 9, going into complex worlds. I learned how to actually turn on a kind of generator that would generate worlds for me. And this was in the era of black and white TV mostly. And in 1968, 69, I figured out how to turn on color TV in my system. And every little kid does this. If you've had little kids, or if you've actually been a little kid, and you have a really exciting day or something happens, and you go and take a nap or try to sleep, there's always flashes going on seems like behind your closed eyelids. Now, every little kid is about 9, 10, 11, 12 years old. I ask, and they say, yeah. They try it out right away. And they see these color flashes. Well, I learned how to dial the knob down of my consciousness. And by consciousness, I mean, you know, thinking about what I need to do tomorrow, that my brother just said something I didn't like, or I lost something, you know, all those sort of task-like things. That I could turn those off. I could dial those down. The color flashes would grow into worlds. And that became my life's work. The ability to dial this whole system down and let where, I didn't know where it was coming from. It was some kind of big broadcaster somewhere. And I figured there was a big broadcasting field because it was delivering this stuff. And then I worked out that the broadcasting field didn't just deliver visuals, it delivered guiding instructions. So I would walk around and I would let this field, I didn't have a name for it, I would sort of call it a field later. I would let it, okay, you walk me. Instead of me being worried about going and giving a baseball back to a new kid that I just met, I would put it in my pocket and let the field wander me around. And the field would bring the kid to me. So I would do these A-B comparisons. Let's do it in mental and let's do it in connection with the field. Let's try it again in mental. Let's then reset, go to the field and just compare one A and B, A and B. And by the time I was about 13, I decided I'm going to use plan B. I'm just going to be guided by this field. And it's a magnificent choreography took over my life. So when at age 14, I committed to work on the origin of life, I said, okay, it's with connection to this field, whatever it is. It's just going to send all the things I need to do and all the signs, but it'll take time. When I was 16, I asked it how long. It said, it'll happen in your early 50s, so be patient. It's just going to take that long to arrange everything. You know, whole fields had to come and go, and colleagues and scientific branches had to, it was a lot, it was a big one. So I'd put the server call out to the field, origin of life. I'd like to actually come up with a solution in the next 90 years or somewhere along that. And it started to work on it. And I would follow every sign that came down the pipe. We'll get that to that later. But 40 years after making that server call to the field, which I'm sort of calling God for geeks, the following, I was experiencing the following. Let's take a look at this great little video. So Matt's
volume up here first.
Volume goes up there. And it goes down there. Whoa. Now the
degrees up here. Going up. The question that we are heading for right now, how certain can we be that that mix of simple chemistry could take the next step in complexity? So life could begin.
In the hydrothermal fields of Butler's Hill, California, all the ingredients of life are brought together. Water, carbon molecules, energy, minerals.
Careful of the animal coming out.
Biologists David Diener and Bruce Daber believe this is the kind of environment where life could get started on another world.
Bubbling pools, strange colored rocks, water of different pHs, all kinds of flows and dynamics, steam rising. It looks like nature's chemistry set. And it's an engine, an actual engine for the beginning of a living system.
Conditions like this defined the early Earth. Evidence of similar environments has been found on Mars. And researchers expect hydrothermal fields to be a common feature of Earth-like exoplanets. But how might nature's chemistry set cook up the recipe of life?
Everything that's alive is in fact based on polymers. Everybody knows the name. DNA, nucleic acid, that's one of the polymers. Proteins, these are amino acid polymers. And that's basically the start of all life, are those two polymers. So what we're doing is taking small molecules, the pieces of a polymer, called monomers in fact, and we're exposing them to energy, such as you see here at Process-Relational, and seeing where that energy is sufficient to make those monomers link up one after another to make a polymer. And in fact, if we can make a protein-like molecule and a nucleic acid-like molecule and put it into a little wrapper, a compartment, we're on the way. We call those protocells.
Each cell contains organic molecules, or monomers, exposed to the mineral-rich steam and heat energy of the fumarole in an attempt to form a protocell.
We think that drying out, such as you see all around us here at Process-Relational, water coming in, then drying out, coming in, drying out, that's a cycle. We think that that cycle is very important to drive the process by which polymers are synthesized and then accumulate. Let's go for it. Failure.
You sure?
Yeah, there's down here. Yeah.
The first experiment fails, just as it would do many times on an Earth-like exoplanet. But if all the elements were present in conditions such as this experiment in life would repeat again and again.
Some of them got a lot of liquid.
It's one last try. Given enough time, and keep in mind, we have an entire planet with lots of volcanic land masses coming up, with lots of puddles like this trying to learn how to become alive. Mostly it's failures, but it would only take a few successful protocells that happen to be able to survive and had learned how to make more of themselves. So go ahead and get them.
Is the universe made to make life? This is a huge question that's sort of beyond the scope of perhaps humans to be able to answer. But what we can observe is everything comes down to cycling. It comes to rhythms and overlapping rhythms and patterns. And it's almost as though if you get the right cycling and patterning in a system, it learns how to do that itself and how to lift itself into being. And so perhaps that's the closest metaphor that we know, that the geology gave us that ability. The moon going around the earth gave us tides. The rotation of the earth gives us days and nights. Rainfall into these hydrothermal fields gives us geysers that are periodic. And life still follows rhythmic patterns. That's the clue we have. So perhaps it's the universal harmonic that creates life.
I kind of look into what we're doing out in the field when I click on the things again. And it's difficult. This is very, very challenging work. I'm going to show you another field work session just after we go back to Charlie Darwin. So Charles Darwin, as Matt had said, left a gap for the creator in the origin of life. Actually, it was toward the end of The Origin of Species, his book. He left sort of a gap for God. That gap may be getting filled within our lifetimes. We'll talk a little bit more about the implications of that. Actually, that's what we're going to talk about when we start talking. So, but Darwin did write something on the origin of life in a letter to his friend J.D. Hooker in 1871, and this is a famous expression everybody knows. You know, oh, what if, and what a big if, a big if. If we could conceive some warm little pond with all sorts of ammonia and phosphoric salts, light, heat, electricity, etc., present, and people remember that, the warm little pond. But the latter part of the sentence is the really telling part, that a protein compound was chemically formed, ready to undergo still more complex changes. Now that describes something very 21st century, which is called an away from equilibrium system. That a protein compound could form, and 19th century science knew that they were about proteins. They didn't know about nucleic acids as much. That it's a long string of amino acids, that it would form, and then it would undergo more complex changes, which might mean it grew longer. Now, normally when you put things into solution, into water, they break up. They don't just naturally grow in length. It's called the second law of thermodynamics, and it takes them apart, takes them back to what's called equilibrium. So what Charles Darwin was sort of had a premonition about was that you needed to have a system that could cycle and form these polymers and get them to be longer and more complex. And by complex, probably he even indicated that the protein would do something. You know, things that are complex do complex jobs. So it's an amazing vision for 1871. And what I'm going to show you next is very new, and it's just coming into publication. Actually, what we'll take a look at is what we think Charles Darwin's warm little pond might have looked like 4 billion years ago on the Hadean Earth, the late Hadean Earth. So here we have a geyser that's just gone off and filled a pool, just like you're seeing in places like Yellowstone. There it goes off again, and it cycles and pulls the water up into the rocks, and then it dries down, and then up, and then dries down. And that's an engine that can drive chemistry. Think of it like bathtub rings in your bathtub. So if you dry your bathtub down with soap in it, you'll find that a bathtub ring forms, right? You see rings around ponds. Turns out those are chemical dynamos. And that bathtub ring is hard to scrub off because it contains layers and layers of fats from your cells and from your soaps and things like this, and it becomes hard to scrub off. And if you actually did scrape it off and looked at it under a special microscope, you'd see it's thousands of layers stacked up. And in between those layers are all kinds of things. Amino acids from your proteins, from your body, are going to be in there. So it's really that bathtub ring that where we think the magic occurred. So in order to test that, we went down, I went last year down to New Zealand because I said to Dave, we're only getting a little product in those fumarole vents. So we actually did get some product from the third experiment, which didn't fail. We got a little smudge, which indicates we got RNA formed from its building blocks of what are called AMP and UMP, a couple of building blocks. We got a little smudge, it was suggestive. And I said to Dave, gosh darn it, we've got to go to a hot spring that doesn't blow everything up. And those volcanic vents are difficult to work with. I mean, they're 200 degrees coming out, and it's quite dangerous, actually. So I went to Yellowstone National Park with a great team and permits, and we actually formed the little containers in acidic and alkaline pools. So I introduced a little sample of that material into these pools and was able to see the little compartments forming stably, which all of our in geology said, "I'll never work." You know, front row Steve, who's the well-known questioner at all conferences. If you're in a talk and front row Steve is there, get ready. So I actually had lunch with front row Steve, who shall remain nameless, and said, "You're probably right, but I'm going to go and test it." So I did, got the little compartments to form, sent him the paper, the draft, and he said he got up at 5 in the morning and read it 4 times, and no one's ever gone and tested his challenge. He's gone and he said it was the great science that we went out and we got it to work, and he said, I don't know why it worked, but it did. So then, so emboldened, I trucked off to Rotorua, New Zealand, where this rock went with me and got named Precious by the creators of the Lord of the Rings film. Got presented back to Gollum, by the way. Gollum was more interested in his fish. But so went to Rotorua, working with Maori in their iwi in a hot spring area. They gave us permission, and they're very much into ancestry. It was just beautiful. The link between the Maori and the scientific quest for ancestry. And actually, one of the things we're thinking of doing to honor them when we go back to New Zealand in February is to create a place name on Mars in their language. And it'll be the first time Maori's ever been used in this way. And it's the place that we would like to go and collect samples where a previous rover found very telltale little stones that the Maori call land corals. When they look at their hot springs, they're little finger-like stones everywhere. They call them land corals, which is very insightful. And we want to go get those things that look like land corals on Mars and bring them back to Earth. And they'll be named in Maori. So it'll be a very big deal. So I get very kind of emotional about it because it's a connection with human history. You know, people care. They really deeply care. So this is the story that was done by the New Zealand Herald. And we get the volume, I guess, back up on that one and down on that one. And this was also very risky. Blew my system out for a week because I was leaning over a acidic hot spring, but it worked.
Oh.
Slide. Great.
Next slide, go ahead.
Okay. So what we're going to show you.
They're muted, so.
Yeah, no, we're going to show you is, let's see, I don't even know what the order of my slides are. Okay.
This one?
Yeah, we'll go to the next slide. We'll just do it. Okay, trying to go next. Click back on the slides. There we go. And I'll click back on the slide. We have to go on the display part. Yeah, there we go. There. Yeah, click. Okay, here we go.
It's just a case of weird science. The lead American scientist Dr. Bruce Damer is at Rotorua's Hell's Gate, conducting research trials aiming to answer the age-old question, how did we get here?
It's very exciting. It's a 21st century science, revolutionary science to watch. If we can find this cycle, it's the engine of creation effectively. Also that we came not from an individual, not from competing individuals, but from a network, a collaborative community was at the tap root of the tree of life.
Dr. Damer's research could turn previous origins of life science on its head. He's testing whether hot springs on land may have been the starting point for life itself. Dr. Damer's searching for RNA, a nucleic acid, and the basis of all living cells.
So we think is that RNA could have been the first polymer that life synthesized first at random in a process like this, and then picked through selection, through these cycling protocells, which we're doing here in the hot spring, picked ones that worked.
For years, scientists had accepted the theory that life began in hydrothermal vents in the ocean. Charles Darwin once speculated that biological molecules might form in a warm little pond, and Dr. Damer believes this to be much closer to the truth.
If we can show to our colleagues and to the world that we can self-assemble an important biopolymer of life called RNA in a hot spring pool that's cycling, in the conditions that would have been around in the early Earth on these big volcanic islands, our colleagues are really going to seriously look at doing more experiments. And it'll create a whole movement, a whole sort of paradigm shift in origin of life thinking, back to Darwin's warm little pond, only now it's a cycling hot little pool.
Jade McLeod, Local Focus.
Of this, which will probably grace the cover of a major magazine in the next few months, because we're about to submit the paper. And take a look at this. I've got to click back on it. So that is basically atomic force microscope image of the polymer we made in the hot spring. So that's RNA about 300 base units long. And we've since repeated the experiment over and over and over again in different conditions. That's what you have to do, and your colleagues have to do it. We figured out that Mother Nature had a way to make the polymers of life at random before life figured out how to make the polymers of life. And it's through this wet-dry cycle. And that was the first time we've actually seen one of our molecules. Normally we see smudges in gels, or we say spikes in graphs to see what, but this is so large that we can actually see it with a microscope. So if I go to a nerdy metaphor, how does life boot itself up? How can you write the programs of life without a programmer? Right? So this goes at the fundamental questions of the creation. And there's a very good metaphor from computer science. And if any of you in this room are over 50, you may have written programs on punched cards or punched paper tapes in your past. Anybody here? Punched paper tapes? Little holes in paper tapes? Well, what if the computer, what if the system that you had no programmer but had a random puncher that could punch random program tapes? And those random program tapes went into a really simple computer. And this is one from my collection called the Altair 8800 kit computer from 1975. And it had a source of energy and it had a cycling system, which is to read each set of holes, punch holes, and into this thing called a processor, which is a very simple thing that run these instructions. And most of them would crash. They'd end up in the crash trash because it's random. But some of them might run. And by running, we mean they might light up a light on the front panel. Bingo. So if that program lights a light, it's fed back into the puncher, and it's new programs are appended to it. So A gets B, C, and D appended to it, and it tries it again. Can it light up a second light? And go and go and go and go. And very slowly and very gradually, you'll turn on all the lights. There will be one strip of program that can turn on all the lights. So it's programming without a programmer through something called selection, combinatorial selection. And over zillions of years, if the programs could evolve the hardware, they might give you a better computer or an even better one until we have, the computers in our hands. And it's the evolution of software and hardware together. And we pay individuals called engineers to do this for us, only slightly more efficiently. So where do we find this in nature? We find this back on the early Earth in that very material that you're smelling from the vial. All of those little organics are coming in from space. They're getting sandwiched in between lipids. The little kind of gummy, soapy stuff that's also coming from space. In the bathtub ring, they're stitching together. See, they're stitching together. They make little paper tape programs called polymers, which is what we just showed you from the hot spring in New Zealand. They go into a computer called Charlie Darwin's warm little cycling pool. It has energy from the sun, and it has energy from the hot spring, and it just cycles like a little CPU. And the programs that are run are called protocells, and they're just random blobs that contain polymers that are random. And they either pop or they do not. So if the little squiggly red polymer stabilizes the bubble it's in, like when you're blowing soap bubbles or a bubble bath, and the bubble's around longer, then it's successful. If it pops, it loses the contents and it's not successful. That's actually the pattern for life itself. If you stop eating, just go on a fast, eventually you will pop, right? So we are still trying to keep the container together as long as possible until the containers can divide and make new ones. It's called reproduction. So really, this is a pattern that sets up, it's like a glove on a hand. It sets up the pattern for the living world to be lifted into existence. And it's an evolution of software and hardware together. Very simple. So if we go on, we take a look at it. There's the cycle. Dry films that bud off these freebie protocells with these randomly sequenced polymers. They're tested as they float around. They either pop or they don't. The ones that are stabilized by what they contain form a sludge. The sludge is the progenote. Let's show you what it looks like under the microscope. There's the layers that are making the polymers. There's the budding that have polymers, and then they're stained with an acridine orange stain, tested. And then they're delivered down to the bottom of the dish because the dish dried down, and the ones that didn't pop are there as a sludge. And this is what we call the progenote. You see the name there. It's a term coined in the 1970s by Carl Woese and George Fox for the unit that started evolution, the unit that went from non-living protocells to the living dividing cell. It's the progenote. So what we think we found is the pathway to the progenote, the boot up phase of life. And it's just a sludge, so it's kind of an ignoble start, but it'll probably get the Ig Nobel Prize eventually. So what this all is, chemists call this a kinetic trap. And all life today lives in a kinetic trap. Your body is synthesizing your polymers faster than they can break down. Otherwise, you dissolve in the shower. So a kinetic trap keeps things going. We're just staying a little ahead of degradation. We're just adding complexity onto the system as it's being broken down at the same time. So really what this is, this progenote, this sludge, is the deepest roots of the deepest common ancestor, the roots of the tree of life. So let's put it all together. So here we have a hot spring on the ancient Earth. Here's our material falling in from space. There's a nice hot spring system going down to the sea. All this great organics that you're smelling from the vial are synthesized in space. They're dropped into pools. They accumulate in the pools so they can get together chemically and do things. They find themselves in a cycling pool, an engine that can lift a more complex thing called protocells or progenotes into being. Those progenotes they're like rafts, or they can be blown like a film, like a dried film. They can float all over the landscape. So they can go from this pool to this stream or to that pool and be cycled, and evolution powering up their polymers. The polymers get smarter and smarter, and they do more and more jobs. And then a wind comes up, blows the material from one pool to the next, and shares those polymers with the other progenote. So it's a huge network effect booting up life. When life starts, it has to learn early on how to eat sunlight. Because once it gets out of that beautiful hot spring pool that's got all the chemical goodies it needs, goes into a lake, it does nothing to eat. So it has to capture sunlight. And so I'm show this is them going green here. Then they adapt to tougher environments, the salty seashore with big tides. This is why we think life can't start anywhere close to the ocean, because when you have salt and you have these flimsy membranes and early polymers, they get blown up and destroyed by salty water. It just can't happen. So none of our colleagues can take seawater and attempt to do the chemistry that we do. It just will never work. So really, it's sort of definitive that life can't start in the salty ocean. And the fossil record is backing this up. So what you're holding in your hand is this lakeshore stromatolite. Here's where you find evidence for life at the lakeshore. Hot spring stromatolite was found 4 years ago in Australia. And this is what it looks like. So they've actually found evidence of life in hot springs 3.5 billion years ago. And then here's some stromatolite from the coast that would have been very much more rugged and rough. And you can see there's a great big towers, great big blobs that have to adjust to big, heavy tides. And this is the roots of the tree of life. So you always hear about the trunk of the tree of life being bacteria called prokaryotes. Well, we may be now into the roots. And this was published, the public heard about it on the cover of Scientific American a couple of years ago. And the big news for philosophy or even spiritual thinking or societal thinking, at the origin of life, there was no common ancestor. What you're holding in your hand is a common ancestor. The bacterial, like the biofilm, there was only a common community. Because individual protocells are too flimsy and fragile to do anything on their own, but together, clumped together, there's power in numbers, and there's a network, there's mutual sharing. So life had to start from a communal complex that was a sharing complex. And if you look through that lens, the long lens of 4 billion years ago, and realize there's no common ancestor in competition. There never was. And currently there isn't one either. Everything's communal. And this is now being discovered in the Secret Life of Trees book. They're discovering that forests are a massive communal complex that use mycelia as their internet. Our bodies are communal complexes. Our city, this city is a massively interdependent communal complex. The idea of separation and competition is a fiction in our heads. So this is a potential important role for philosophy. So if we go on, let's quickly skip through this because this is going to give us some clues. So back into philosophy, back into sort of Whiteheadian views. What is the unique thing that takes life from physics to biology? What is that question mark? Is there something unusual and unique about that transition point? It's the point of creation. And if we can rewind or unwind life back to its actual start point and read its earliest boot code, we can learn something that will teach us tremendous lessons. So I did a thought experiment one night where I asked the field, going back to it again, because it's sort of my peer review and it's my greatest teacher. I asked the field, so like, can you show me how everything started? You know, because I've been asking it this for 45 years, but it was in a particular frame of mind that I was able to have some clarity on this. So the field showed me the undulating plane of physics. It said push down on one side, and I pushed down on one side and it undulated in a pre-statable way. I said, oh, fine, that's physics. I said, yes, and that represents the universe for 10 billion years, very unproductive, right? The universe hasn't cranked much complexity out in 10 billion years. If you go back 10 billion years ago, you'll find similar stars and galaxies and similar stuff, right? Just fewer, heavier elements. Same dust, same this, and it's not very productive in terms of complexity. It's really kind of unchanging. But then what happens one day is this magical thing appears, amphiphilic molecules, lipids, or think of them like soap bubbles, a very special kind of molecule that can wiggle together and form membranes, that can self-repair, that can self-divide. It's a magical molecule. And there's a whole manual, Merck manual of amphiphiles. I mean, amphiphiles are everywhere. We're made out of amphiphiles. This body is mostly cell walls, it's phospholipids. So the magic molecule appears and it forms vesicles. It forms these little bubbles. And within the bubbles, things can get in and crowd together. And that's a special property. And we'll get to that in a second here. But these bubbles can also get next to each other and they can transfer stuff back and forth between distinct places. That's really hard to do in pure physics. This is the emergence of a kind of a network. Then, if you get a sludge of them, or ignoble sludge again, you get transmission of stuff throughout the sludge. That does set up a network effect. A network effect is brand new in the history of the cosmos. Stars don't do it, geology doesn't do it. It can happen here just through self-assembly. And so the great big field professor in the sky that I was talking to said, okay, what do you see? And I said, well, I see that the bubbles are shaping probability by crowding things together. When things are crowded together, like we are in this room, we can have conversations that we'll never have because we're not together on the street. You know, the probability of cool things happening or being discussed goes up non-linearly when we get together. Then there's a second thing, when we get a lot of us together and start message passing, interconnections can start. They go non-linear too. The more bubbles you have, the more interconnections you have. It's non-linear, it's powerful, it's a power curve. So the great big field said, what do you think happens after that? I said, I don't know, maybe some kind of a memory system? And I said, bingo. On top of this can come a memory that can be written and read each generation. And only on top of this, that's the genetic polymer. So what it then showed me was a three-way triangle. Thing that shapes probability and rolls the dice constantly, but it's really good at rolling the dice and getting sixes. A thing that can connect and pass symbolic messages around like crazy, and a thing that can then write a memory and read it for the next round, and write and read and write and read. And the voice came, this is what creates everything. This is what brought life into existence. There is nothing that is not inside the system. This is the total system. This is the engine of generation, or an engine of creation, and the engine of generation of all experience. And this is all technology. It's all, everything is explainable by the interactions of these three things in Segall. So I thought, well, I was presenting this in the last 3 years at conferences, and somebody in the, annoying Steve in the back row, putting his hand, or Charlotte, saying, are you proposing some kind of new Copernican center or new Copernican concept? I thought, I don't know. What did Copernicus do? He looked into the sky, he figured out that planets went around the sun, not the earth, and he very, very wisely published the paper after his death so he didn't lose his head or his funding. And then Galileo got in trouble for it 70 years later. But when the Copernican revolution happened, it was big because it showed that we weren't just the only world. There were other worlds. We weren't so special. We weren't at the center of all. And it started a scientific revolution. Well, and the new maps of the cosmos look like this in those years. So I thought, what about this PIM thingy? Is it really at the center of many things? It seems like it could be. That it's a general principle for the lifting of chemistry into the living world with geology. It's actually a formalism for physics, the first time physics has ever been able to self-assemble linear information. That's what our colleagues at UCSC are telling us. It may show us how life can arise in the universe. It may be the fundamental principle behind all of evolutionary biology. And I'm now presenting this in Cambridge and other groups in the UK who are looking at extending evolutionary synthesis. Who knows? I showed this to Ken Wilber a year and a half ago, and he said, this underlies and is the basis for my work. Because it's the set point, it's the start point of all of those spirals and all of those holons, and all that complexification comes from this. So that was pretty cool. Deepak really likes it. Every time I meet him, he liked holding Precious a lot too. We're now talking to Google that this PIM thing may help create a revolution in AI, because AI is stuck. AI is just a bunch of linear algebra run through a freaking huge set of processes and huge, basically these networks with feedback bias loops. It's clunky. And it requires manual training on huge data sets to work. It does not use the power of evolution, unless you think of programmers evolving and the next generation of programmers doing a better job. It does not. So we've been talking to Google about how to bring this PIM formalism into AI, and that AI should have genes. AIs should compete with each other in a vast field to learn better handwriting recognition or something like that. And it's going to be possible. And we're rethinking computing architectures to do this, because the old Johnny von Neumann hourglass CPU is not going to cut it for this kind of work. So we have to reinvent computing in order to be able to do true learning, biologically inspired AIs. Maybe it's also the basis for a better economic model. So I want to summarize by giving you a long path. And I know Matt showed the history of the cosmos in his last slide. But the physics of the cosmos seems to be just an on-off cycling system, state changing. Stars form, they blow up. Particles change states, things collide. It's a state engine, but it's only really a two-phase kind of motorcycle engine. But when you get life, you get memory, you get biology, you get memory, and you get the PIM, adds a third phase, and suddenly complexity just goes rocket straight up. But beyond that, you get another phase, neurons, which allow learning and adaptation within the lifetime of the organism. So we call that a fourth phase. This comes from Daniel Schmachtenberger. Then when you get enough neurons packed together, you get consciousness. So what is consciousness? For our purposes, maybe the definition here is something that's able to think and reason and plan for the future and recognize itself, something like that. I don't know. But perhaps it's this PIM cycling system that generates the substrate for life. It's also spinning and spinning and spinning and generating everything else at a higher level, and that it actually is responsible for all observable phenomena that we model in our heads and observe with our senses, and even all felt experience. Is this continuous cycling of this system. It's a proposal, and that human consciousness is only sampling a tiny subset of this experiential field. And what I want to show you next, beyond this, this is the complete view. Physics cycles into, this is what Ken Wilber liked a lot. Cycles into consciousness and goes somewhere. Where does it go? Let's take a look. What happens when the entire cycling system supports awareness looking back on its own origin and evolution? What does that do? You sitting in the room right now saying, oh my God, this is where we came from, 4 billion years of improbable events, and we're sitting here, there's kind of an opening happens, an opening to awe and wonder. It's perhaps a big opening, it certainly was for me. What I'm predicting is that it's this, the experience of unity consciousness, when a being is not only aware of itself and its feelings and its environment, but of its total origins, its lineage all the way back, its place in the cosmos, its improbability, its unlikelihood. You know, that this is like an aha moment. It's one of the great aha moments. Perhaps that's what this is. Now, there's a way to test this. And I'm going back to when I was a little kid and doing this field testing, you know, first getting the visuals and then getting walked through the neighborhood. And I started to think over time that what happens in this God for Geeks thing is you make a server call into the field and it starts organizing stuff, and then it sends signs to you. And this is completely within human literature, you know, 1,000 years of literature describes this. And all of us have had miraculous lives, I think, where this happens. If you maintain a clear vision and a hope and a dream, the little marbles start rolling towards you. And could it be that just as in the earliest protocells, which shaped probability by crowding things together to make them able to survive and do unlikely things, like get proteins together with RNA and then make stuff so they could become living cells, how so might our conscious minds act with this collective field, this huge matrix of soup we're in, the field of probability, to use the following three things. Intention, that vision of, I'd really love to have that come true one day. Attention, waiting for things coming back from it. And action. And let's see how this might work. So here we are, our little cells. And we're in the present. And we have an intention to get to a certain place. And we don't know what it looks like, but we can have this kind of beautiful imaginative flowering of like, what if this happened? What if I became a great dancer? What if I started a vintage computer collection? Or what? And you really held close to that, held that close to your heart, close to your mind, close to your actions. What might start happening is these little marbles will roll down. Oh, here's the first vintage computer you can collect. Oh, I'll collect that and I'll study it and I'll reach out to the people who made it. And another vintage computer arrives, and before long, William Shatner showing up at my DigiBarn to film an episode of Star Trek, which he did. And he beamed me into the Cray supercomputer because it was made by a Star Trek fan named Seymour Cray. So miraculous outcome, the future, happened by shaping values of probability that each time you pick things up, this is very much like relativity theory, these marbles are actually shaping probabilistic landscapes that you can then traverse. And when you look at the miraculous stories of how people achieve things, and all of us perhaps, you think it's completely improbable. Carl Jung called them a synchronous field. He called them absolutely outside of probability, that he would be talking about a red car and one would drive past the window at that moment. You know, he talks about this in his work, The Synchronous Field. So you can test this hypothesis in your own life. Do the God for Geeks, do the server call to the field, pay attention, take action, and measure outcomes. You can kind of formalize this. But all of this reality, all of this system is driven by one thing: the rotation of the Earth to face the sun. simple one thing. The Earth had starting contents that could lead to life beginning on it. And the fact that it rotates and faces the sun, every morning you see that sunrise, you get that powerful incident solar radiation come in, it spins PIM. It spins individual chloroplasts that generate the sugars and starches and the energy that is needed for plants, which then you eat during the day. You digest, you do your thing, you go to sleep, cycle, 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 cycle. The master cycler. And there's a way to test this too, which is to take the Earth, let's just get an NSF grant, take the Earth out of solar orbit for like a week, where there's no sun rising, and see how the biosystem crashes. And it will crash so fast and so totally, because it's exquisitely dependent upon that sun being there every day. So when we get into our big hubris state that we do as a species, we should remember we are exquisitely dependent on one thing, and it's the master cycler, and it's this process alone. So last bit of this, and then we'll get into the discussion. So having gone through all this, having studied sort of the origin of the universe, having studied, well, where did complex matter come from, having done a computational PhD on how does the universe complexify and not lose its complexity, and then taking those results into the origin of life and actually doing the experiments, doing the thought experiments and then the physical experiments to find a plausible path for life's beginning, then being very interested in consciousness, very interested in the field, right, in this incredible thing that we seem to be in. I decided one night, this was at Moss Beach, you know, it's just over here, I was sitting out on the sand at sunset. I said, I'm going to address the field. Sometimes what I do is I say, field, I see you. And I often get an answer, I see you. Ah. And then I'm completely in sync, then it's a completely different reality at that point. But I said, tonight I'm going to address the field with an important question of pointing out. I'm going to say to the field, and the sun was setting just on the distance over the Pacific. I said, and the cosmos was coming out. It was a beautiful moonless night. I said to the field, wherever you are, if you represent the entire universe, or just you're of us, or whatever you are, you're kind of bigger than us, we need you to pay attention, please. Pay attention to us. Pay attention to the rarity and beauty of this earth and the improbability of intelligence rising on the earth. Pay attention. It needs to have focus. We are so extraordinarily rare and we're at risk all the time. Existential risk is trying to pull us down all the time. And we're sitting at the top of a 4 billion year evolutionary improbability. And suddenly in my vision came this image. And it was a living sculpture. It almost looked like an icicle. I called it later the silver spire, and it was seething, absolutely seething. And what it was made out was this cycling. It was showing me how the innumerable trillions of risings and settings of the sun were able to stack this fantastical form up and lift it and lift it and lift it against all odds. And it had started with all this makeup of all these fantastical heavier and heavier elements and molecules. And that it had started here in this hot spring. And its wide body, the girth of the body, was a microbial world. And the microbial world was stacking and getting more complex. And then what happened through this fantastic engine that was running continuously, this PIM engine, it started to generate something beyond just the slimes at the edges of the pools. It was generating something bigger. It was generating almost like an Akashic record of memories. And the memories weren't just the genes of the microbes, because Earth's history is about 90% microbial, right? It's really 90%, it's mostly a microbial planet. What it was doing is generating a massive record of memory at the same time as it was generating more and more interconnects. Even in the microbial world, the system was getting denser and denser and denser, so that when there was a huge impact on the Earth, it could recover faster. Or when the Earth froze over completely and it was almost extinguished at one of these points, it was able to come back faster. And then it finally got control of the thermostat. Gaia was born 800 million years ago, and Gaia could control the gas content and temperature, and Gaia was born, and we live in Gaia. And all along the way, this amazing thing was happening, that it was becoming less and less probable. So all the way up to here, say where we have complex organisms, see those blobs there, they were sort of moving around in the spire. Complex organisms were incredibly rare in the universe. After 3.5 billion years, there were lizards running around and fishes and things like this that they're completely improbable in the history of the cosmos. They were there, and suddenly we came into being, and this happened. Conscious self-awareness. We woke up one day and we started depicting ourselves. We're beings. We're not just doings. We understand the sunset and the sunrise. We can anticipate it. We can use ochre and we can paint in the caves at night. We develop culture, self-awareness, story, allegory, tools. This happened right here. And then there's this thing in our futures. And I'm going to sort of zoom in on that a bit. So we climbed a 4 billion year process up through conscious self-awareness and the waking up. And now we're here. We're here and we're being slammed by cycling faster and faster and faster and faster. This is what's happening in our time every day out on the street out there and in your hearts, in the environment, going through these incredible pressure waves of testing faster and faster and faster because evolution is pushing faster because this field is more densely interconnected. There's more memory to work with, and there's more probability to shape. So the engine of probability, which is what life does for a living, life just shapes probability and brings miracles into being. It's now at the level of us. And we are waking up as one organism. We're becoming so densely interconnected. We're becoming a single organism. And this is the vision I had about a month ago, which was this crawling amoeba-like thing. And I said, what is that? And the answer was, that is you. It's not Gaia. It's not the cosmos. It's not an entity. That is the collective animal of human beings waking up, becoming one organism that will survive, because all life has the will to live and the intelligence to figure out how to do it. So no matter what is in our anxious minds, our body, the body of human beings and all of its technology and all of it is a force. It is a living force. It is going to make it. So what happens when we get here, the prediction I have for here is this is already happening. Many human beings out there are coming into these flashpoints where they see it all. Could be non-dual unions, could be samadhi experiences, it could be from psychedelic tools. They're coming into these flashes of awakening of the totality of all their origins, the whole universe, all the atoms of their body. They come in these flash and they experience it, and then they drop back down into sort of daily life, and then they go back and they flash. And this is only happening to a handful of people 2,000 years ago. Now it's happening to millions of us. And collectively, this is doing this collective waking up. And when you reach this point of complete awe and complete surrender, really, in a sense, to the magnificence of this, it totally changes you. And this is way beyond awakening. It's way beyond the traditional religious explanations. It's something new. It's something new because it's being done in the context of this densely interconnected, highly probability shaping, replete with memory field that is what's called a giant resource. So healing can happen faster, insights can happen faster, inventions can happen faster, samadhi awakenings can happen faster and more frequently because of the thing that we are inside. So thank you.
Wow.
Wow.
Thanks, guys.
So sit with that for a sec. Take a few breaths in. You know, what's so exciting for me, Bruce, is, you know, I've always wanted to think of life, as I said earlier, as a cosmological achievement, right? And your hypothesis, which I know is, you know, more and more people are starting to collaborate, and it's really making headway. And I hope that the pieces fall into place so that we can understand our own origins and get a sense for our ancestry. Because, you know, science is about theory and experiment, but it's also, it has a narrative dimension, especially evolutionary science, because evolution it's historical. And there are these events that occur. And, you know, time in an evolutionary context is not just, you know, a sort of quantitative thing like a line on a graph. Time is creative advance, as Whitehead would say. Time is the evolutionary process. It's never the same twice. It's cumulative, right? And when you get to this point where these protocells emerge and then more complex life emerges, you get the capacity to learn. And so the probability engine kicks into high gear. And whereas you said for the first 10 billion years, you know, I wouldn't say it was boring exactly. There's lots of interesting stuff happening with, you know, the particle zoo and all the elements forming in stars and galaxies, a lot of interesting complexity. But it's like there's maybe a handful of different kinds of stars and maybe 2 or 3 different kinds of galaxies, and you don't get the explosion of creativity that we see with biological organisms until this PIM cycle starts. And so I think at one and the same time, we're trying to see this as one continuous evolutionary process with these tremendous phase transitions. And how do we make sense of emergence? There's order for free, right? So you talked about a program without a programmer, this PIM cycle. But in a sense, you know, to use your metaphor, to get the lights to turn on, you had to have a pre-installed program of some kind, right? And I think the physical world gives us that because there is some informational content there. There's some interesting stuff going on that allows, for example, these lipid membranes to form. They just spontaneously emerge, like they bubble like soap bubbles, right? Life didn't have to figure out how to do that in an evolutionary process. It's just order for free. And so there's these little sort of pushes that the physical world provides that allow the booting up of life to take place. And I find that really interesting. So let's open it up for a broader discussion. Yeah, please.
Yeah, for Bruce, but also maybe David, and I really don't know enough to really even ask the question, but I'm going to try. But when you were saying that, you know, the communal maps of vesicles have the ability to exchange information or contents, and that stars didn't have that capability, and immediately when you said that, it reminded me of an article that I found really fascinating. I read a number of years ago about some scientist had the theory that when 2 different disparate sources of light, say 2 stars on either end of the galaxy, when their lights traveling at the speed of light came in contact with each other, that instantaneously the 2 sources were no longer the same. And I'm just trying to maybe equate that, that maybe in the case of, you know, the vesicle mats, that's a chemical exchange, and that light has a similar ability in its own. And I don't know if that's something you thought about or can.
It's not my department, but Nick Herbert, who's my neighbor, is a physicist who worked on Bell's non-locality. Wherever I try to equate that to kind of an internet of things, he always slaps my wrists and says, "You're thinking classically." You know, and so Nick's whole life's work has been to put his mind into this quantum, non-local, entangled world and try to make sense of it from a kind of monkey logical Cartesian thing, and he just can't do it. And he said, it's so weird, it's so strange and non-intuitive that we can't cast our minds there very easily, our consciousness there very easily, and yet it manifests this. So that's the irony, is that this crazy system that is internetworked manifested the physical world of the classical world, and life rides on that. And life actually learned how to use that with photosynthesis and probably the microtubules in our brains. Life harnessed something about the quantum level. And when we look at the origin of life, we question whether is it all physical chemical processes, or is there a quantum nature to it? And there would have been, as when photons started to get captured, and however that was done with some early pigment. But this is a huge, great, big, vast unknown. And this is maybe 21st century science's greatest mission, is to discover the network, and to touch it and to read it. The network that is the quantum domain, the network of life itself, the network of our culture. And how does our culture, like right now there's within the network is coming a lot of toxins and a lot of viral content in terms of fake news that's generated by us in order to provide advantage, or in a sense extract from the system, as advertisers have done for generations. But this has now gone completely crazy. So it's a viral load that has now come in to the network of us, of our sort of cognitive news-seeking personalities. How do we respond? How does the immune system respond to that viral load? Because a viral load could kill the body. And then there's this field, the healing field, the synchronous field, which is totally above and separate from all that, news stream and social media. It's not, and yet that field infuses that too. Because you'll find, you're on social media and you think of something or other and boom, it comes up. And it wasn't Google's AI that figured it out. It's like, whoa, that's really spooky. I didn't do anything. I just had the thought and it came up. Is it reading my mind? No, I think the field rocks in social media. The field expresses in social media. Just as Newton would have received a letter from Leibniz at just the right time before going to the Royal Society meeting to talk about the calculus, and says, doggone it, I didn't come up with it. That's sort of, these things are probably happening in the 1600s as well. The field was rocking the technology of the day. So it's all about fields. It's all really, and the field is both a nerdy term and it's both a spiritual term. So it's kind of cool. It's kind of neutral. It's not a person. It's an OS, and it's an OS that we can interface with. And it's the OS that will make the difference between we are here in 1,000 years and we've settled our entire solar system and we have a vibrant civilization that has restored our Earth, and whether we're not. That the field is the tool for our future. I'm convinced of that.
Segueing into that, Mars, you're in NASA. What are the projections for bringing that substrate back?
Well, currently, I'm currently involved in an effort to design a sample return mission that would be a pick and place kind of really fast mission. Because currently we've got another rover going in 2020. I was on the landing site selection process for that, and we selected a river delta that was going into a lake. And it's going to give great geology, but probably no evidence for life, because river deltas on Earth are just jumbles of stuff. We need to find an old preserved hot spring, which we did with another rover earlier. So it's going to be a challenge to find evidence for past life at the surface of Mars. It's a very sterilizing environment. It's a terrible place to try to build a civilization. It just doesn't make any sense. We have to drill, and if we drill, we've got to drill deep into hot, wet, salty rock and see if we can find bacteria halophiles. But Mars is an interesting case. It lost its liquid water at the surface a billion years in, and it was super salty. So could these fragile membranous protocells ever form in that environment? Venus may have had oceans, but it lost them due to the fact it was close enough to the sun. So we truly are in the Goldilocks zone.
Venus's orbit kind of froze, or its rotational axis froze too, so we didn't get that cycling from the sun.
Yeah, so it's the Earth is, I think, Ashton, you had a,
Did you want to finish?
no, go ahead. Go ahead.
Okay. So I'm just curious, in one of the clips you showed, you said perhaps it's the universal harmonic that creates life. And so just thinking about that in relation to the PIM cycle, and also just the language of the synchronous field in relation to Jung and synchronous harmonic having some kind of similarity around composition or choreography. And so bringing that into conversation with entanglement and the kind of pre-modern notion of the sympathy of things. And so I guess my question is, with all that in mind, thinking about like rudimentary forms of memory before, I guess memory was, as it's expressed in life, something that retains and then reads. And I think the habits of the solar system might be a good example of that. But just so that there's like some kind of continuity and just this notion of harmony and synchronicity sort of not being easy to parse with random.
I think that there's something going on which is not in our purview. It's not in our view. These networks are so much greater in scale and scope than prosimian or simian consciousness. And all we can do really, in a sense, is take an adapter to the end of our telescope or our microscope and twist the lens and see if it brings something else into focus. And we have all these practices to do that, to see if we can see more, because we have really a limited scope. We're kind of like running with blinders. Now, the language of mathematics takes us out further. The language of meditation or of spiritual practices can take us out further to see more. We can get tricked by our own stories. Even our own math can trick us and send us down rabbit holes. Einstein worked for 4 years going down mathematical rabbit holes before he cracked general relativity. He was just mainlining tea in his apartment in Berlin. That's the tools he had. But it's an incredible time that we can do this. So we could actually put the intention out that I'd like to ask the question, do the winding orbits of planets and solar system constitute a memory, constitute a genetic code, or a gene rather? And then you can go and study 3,500 exosolar systems from Kepler. You could immerse yourself in the literature. You could look at all the models.
Incidentally, Kepler had a theory of the harmonics of the solar system. It's funny they named the satellite after, for good reason they named it after him as a planetary astronomer, but he had a theory of the harmonic relationship of the planets and their orbits. Yeah.
So you could take that on and put your intellect or the field itself onto that problem. And you might get a glimmer of understanding, like, wow, there's an evolution that happens in solar systems, and there are annealing points that pull them down. And then there are these instabilities that take some of them out. And while there are no genes, it's all what's called a compositional organism in Whitehead's term. It's compositional, i.e. there's no memory that's written and read. There's no blueprint. It's just the way it is. It is its information. But you could do amazing, almost spiritual, like flash intuitive work on these solar systems. You could set your intellect and find the patterns that, say, hardcore, more reductionist people who are just looking at individual things will miss. You can do your consciousness thing, wind, and come up with fantastic insights onto the evolution of solar systems.
This question about memory in the physical world prior to the innovations of biology with the genetic code and even the simple cycling of progenotes, matter is energy, energy is vibration, you think of a waveform, from moment to moment, you know, a photon maintains its waveform through a very simple form of memory, I would say, right? As the, you know, the frequency of the wave, it has to persist through time. That's a very simple form of memory, right? And this is like a Whiteheadian take on what energy is, and a process take on what the material universe is that it does require a simple form of memory to continue to persist, to continue to exist. It's not just mutely enduring, it's a vibratory pattern, right? So there's a very simple form of memory already present.
In life. So it's the
Right.
life that is feeding that life, feeding memory also, because that it is.
It is, yeah.
It's memory that's being fed into that.
Now there is
Sludge.
a disjunction point, and it's what we're after now. So we feel in our science, and there's papers every week now. It's a storm of papers. It's a deluge that's going on. I just reviewed a NASA grant this morning that if it's funded, will be a huge advance if NASA picks this team. But here it is. You have protocells. We're able to form them. We're able to get polymers in them. And then teams are getting ready to cycle them and see what functions emerge. Does a pore form in the membrane? It's selected by random, but then gets copied because a pore is a polymer. It might get templated by sliding around the membrane, slamming into something else and making a copy of itself. So now you have a membrane full of pores, which is more stable because it's got pores and stuff can get in and out. So it doesn't pop as easily. There's a way of stuff to get in and out when it gets too fat or too weak or too small. So people are going to start looking for the emergence of functions. But the great chasm that goes all the way to the living dividing cell. When you think about the first protocell that's able to do this and pull itself apart with a complement of tools, genes and various tools and proteins and whatnot on either side that allow those things to do this again. That's a gigantic machine. That is a hugely complex machine. So what we have to do, and this is the realm of thought experiments, is to put our intellect at that in the Progenian epoch, carrying across that chasm. What I've been doing for about 10 years now is going backwards across the chasm. I've been looking at all the things that you need to have to do this and trying to find backwards through time how they could have emerged through just selection and pressures alone. Because the only mechanism you've got without having a creator or a synthetic biologist that's just plunking things in, is you've got to have selection barriers that the population comes up against and surmounts and then invents something, which then stacks on the next thing, which allows the next thing to be invented and stacked again and again and again. When the whole system crashes constantly and all the stuff is lost and it has to restart and restart and restart, like pin cushions coming up. Just crazy. So the Progenian epoch, probably between about 4.2 and about 3.9 billion years ago, was one of massive catastrophes and starts and failures and starts and failures. Almost planet wiping out asteroid impacts, tsunamis 4 miles high, acid rain, you know, look at all the things that were going on in the early Earth's history. But so these islands that are full of trillions of progenote colonies that are struggling, they reach a certain critical point. And so they go, and this is where what the magic inflection point is. And this is perhaps where the philosophy and the biology and the science meet. The magic inflection point is where, you know, when you're starting an engine and the sparks are just the right timing and the fuel is the right mixture and the engine just kicks in. You get enough fuel, it ignites, it pushes the piston down, it turns the camshaft, it runs, it's just right, and then the engine just goes. That's the point we're looking for now. That point, what has to be there for that? What has to drive that? Because proto-life up until that point is passively driven by what drives cycling, by the feed. It can't even make its own food. It's got to get food from the environment. And then it gets to this point where it starts making its own food, reading and writing its own instructions, and it can respond on its own to stresses and explore space, explore evolutionary space, problem space, solution space. It is effectively an élan vital. going. It is actioning, not being acted upon. It is growing through, in a sense, the philosophers of Terence Deacon and Jeremy Sherman would call it striving. Now, these are terms that would never be used in our science, right? But this is why we're sitting here at CIIS, right? We can use these terms, but the ignition point, when the system starts to what Varela called be autopoietic, this is the point. So the origin of life is now divided into phases. Instead of it being this mysterious one thing, no, we have an experimentally testable early zone. We have genes and gene studies going all the way back into the prokaryote world and hints of earlier forms like the primitive ribosome, hints of that coming down from here. And then we've got our intellects to go and run experiments and computers potentially to run experiments through this big dark zone of where did the ignition start. And then here's, for me, it's the most I get the most both tremulous and excited and blown away by the potential realization that getting to that ignition point was vanishingly unlikely under any circumstance. So what chemists or biologists in the room, evolutionary biologists, will say, well, gee, if you can cycle a system in a pool and get these protocells to form and by their trillions and then start seeing functions arise, well, life should be ubiquitous in the cosmos and in any circumstance. And I say, not so fast. Not so fast, because the OS has to be really damn good to divide a cell. It has to be damn good to survive distribution and the lack of resources, the sudden taking away of resources. These are physical, chemical, self-assembled systems that crash really easily. And it's on a landscape. It's not in a laboratory. We're not ordering stuff from Merck, right? It has to get what it's got, and it has to have the right snow falling of interplanetary dust particles to feed it just right. And it's like, wow, this thing may be exquisitely uncommon. So if that ignition point, even if life can get to an ignition point, it has to stay with the ignition point. It could get wiped out very easily. It has to distribute quickly. But it's like, it's a ratcheting. So it's grabbed its little knuckles onto that one cliff that says, I am alive, I have some volition, and then the cliff falls away. Because it's the early Earth. You know, it's horrific environment, horrifically degrading environment. So in a sense, if there's anything, I don't think, for me, there's anything more deeply spiritual than putting my intellect or my consciousness back to that point when ignition occurs and sending it hope, sending it my gratitude that this did occur and it stuck. It stuck against all odds just to get to dividing protocells, just to get to microbial colonies, to get to that stromatolite that you're holding. That's a miracle beyond miracles. And then, of course, the rest of the 3 billion years of Earth's history where those bacterial colonies had to survive and then generate eukaryotes and generate complex things and put enough oxygen that we could breathe. And then all the right things that led to monkeys getting selected, prosimians getting selected to be in the position we are, Africa splitting in the middle at the right time to throw our ancestors into the savannah. You know, and as we come up today, we've just heard announcement that a major venture capitalist is joining our climate mitigation group, which I'm starting with US military generals and admirals and fantastic innovators and whatnot. As I woke up in March thinking, all this wonderful work on philosophy, all this wonderful work on the origin of life and the future in space is going to go away. Institutions like this will go away if we come under assault from climate shocks. We're going to lose most of it. It's going to be on hard drives somewhere, but no one's going to be actively working on much, except surviving in the Bayclave, for example, and keeping people in or out. You know, these are Hollywood visions, right? So do we want that world? No. So I woke up thinking, climate mitigation associates, we've got to start a network. We've got to do design and awareness in the 20s, and by 2030, we have to be under massive construction all over the planet to get ready for these shocks. we need living seawalls. We need to adapt Central Valley agriculture for hurricanes that are going to come up through the Gulf of Mexico and hit right into the Bay Area in the summer. That is going to happen. We need to adapt that. We need to do every innovation we've got because we're in that top part. And as our spiritual awakening happens, this challenge from the mess that we're making is coming, and it's going to spiritually awake us. It's going to unify our planet and our species. But we have to start getting together like the progenote, like the network, and working really tightly together in a healthy body. And so that's what we're starting with this climate group, climate moonshots as well. So that's just sort of what happened at dinner. I got the call that a major VC has joined. And we're probably going to get the incubator that will help to come up with this stuff. So all of that said, the hope that we have is that we are creatures of stresses and climate shocks. We were thrown into the savannah. Our ancestors did walk into Europe, into the toes of advancing glaciers. We are creatures of climate change and rapid climate change and adaptation to it. So we're pre-adapted for this. But it is the great force that is going to force everything. PIM again is going to force all of our knowledge, all of our interconnection, all of our probabilistic dreams through this pipe. And at the same time as we do the infrastructure to preserve ourselves and say, do we care enough to preserve our civilization? So we have air travel, we have medical care, we have education, we have science, we have the arts, we have theater in the 2070s. Do we care enough? Because once we decide we care, all that other noise can go away. We can just say, we are not listening. We care to preserve this in toto, not just mine. We're going to preserve this planetary civilization. Because if the climate shocks are severe, the methane release is a 500 to 1,000 year violent Permian-style climate event, as depicted in Blade Runner 2049, right? So we should just get ready. So that's sort of where we are in the little jaggy part of the thing. We can't wake up to the totality until we take responsibility and we pay attention.
Yeah, I mean, there's real hope in the mythos of your science, of this hypothesis, because as you said earlier, we didn't originate from these competing individual cells. That's a very advanced technology that came much later. We originated in these progenote communities, sharing their genetic innovations with one another. And I think that as an origin story gives us a new mythic basis to found a future civilization based on other principles than just individual competition. There's room for markets and competition, but if we don't find a way, as you're saying, to come together as a species and collaborate and share, then there's nothing left.
Yeah, and I think we will, and that we should get a few more questions.
Also, anyone who's online that wants to
yeah.
unmute.
Are you unmuting?
And ask a question, please feel free.
Teilhard said it was only about the caring as well, the zest for living, the hope. It is precisely the pressuring together that will make us rise.
Oh, yeah, Teilhard de Chardin.
Yeah.
There's a question in the back here.
So, in your PMI cycle, one of the implicit things you have in there is that there's a tendency or a force towards increasing complexity. Do you see that as being something fundamental to reality, or is it rooted in more physical laws?
I think it's almost like going back to Whitehead. It's both. So it's deeply rooted and implemented through physical laws, something super physical that is sort of beyond what you could ever get through the cloud to identify the physical start, even though you know it's under there and you're a body and you ate breakfast so that you could have these thoughts, and probably had coffee so you could have more clearer thoughts. But the totality of what it is so large, it's very would be impossible to kind of take it apart. So, and I think that's where we go into, but that we can have the faith that it is generated by a substrate.
How do you reconcile that with thermodynamics?
Well, in a sense that it's thermodynamically based. It's absolutely based on a footing of thermodynamics.
It runs on entropy.
It runs on entropy.
Another, I mean, you know, the gradient produced by the warm sunlight coming in and deep space, which is really cold, that gradient is the surface of the Earth. And to cancel that gradient, to return to equilibrium, life, the complex activity of life is way more effective as a gradient reducer than would just rocks and inorganic chemistry be. So life is actually producing more global entropy, canceling the gradient between the warmth of the sunlight, and it's doing it faster than if life never emerged. So it's not against entropy, it's using entropy.
And spiritual awakenings always come through highly stressed periods in people's lives, from the Buddha himself to all of us. It's always in these steep gradients of pressure and stress and uncertainty. In Krishnamurti's case, it was the deep grief from the loss of his brother. And then he gave up on all. He didn't know what there was to live, and went and walked and sat under the pepper tree in Ojai, and boom, and it was never the same. So in a sense, it's the same thing. It's these gradients and stresses, and the thermodynamics are almost like emotional thermodynamics, where your system is being pulled apart at the last possible minute, and you just can't imagine going on. You're at the point of disillusion, and then it allows this thing to come in, which would be...
That's how we've come to be in this state through evolution, correct? Just constantly trying to find the best way to exist under these strenuous, stressful conditions.
Yeah. As precarious as the process has been all along, because life learns, it adapts to changing conditions, but every time it adapts and survives some cataclysm, it remembers how to respond to that sort of cataclysm in the future. So it becomes more and more robust over the course of evolution.
And what happened, I'll tell you the last piece of what happened in that night with seeing that living spire. So what occurred was, I was in awe of it. It was so beautiful. I was just awestruck by it. And then suddenly there was this black shape appeared toward the bottom that was starting to occlude it, almost to try to break it. Because I realized it's like a crystal. It's super fragile. You know, at any moment, a thermonuclear winter or a huge global pandemic of some sort, or meteorite, it's gone, right? It'll break it all down. And this black thing appeared. And I thought, wow, your degradation, you're the second law, you're whatever you are, you're a threat to this whole miracle. As I've been calling out to the cosmos, pay attention, this threat appeared. And I thought, how do you respond to that? What do you do to this ever-present threat to this precious thing? And I thought the only thing you can do is give it your attention. So I focused my attention on that black thing. It was almost snake-like, that's part of our mythos, right? It's moving around. I said, you bugger. I know who you are. I know what you are trying to do, because you are trying to do what the cosmos itself is its fundamental mandate, which is to dissolve all this complexity back down to the total equilibrium. That's why there's more expansion. That's why Guth is probably right. This is why it's expanding. And so there's this enormous force against this 4 billion year complex, gorgeous thing to pull it down. There's a potential force, but it does come as an existential risk. So I focused my attention and took everything I had to say, I'm gonna track you. You're not gonna be out of my sight, you bugger. And it started to move more rapidly in a kind of rippling way. And then I watched it and I said, I'm not letting you go. I am paying attention, I'm watching. This is intelligence, this is care. This is knowing and wisdom watching you. That's all I can do, is to watch and pay attention. And it folded itself, it folded light, and it went out of the universe into another physics where I couldn't follow. I thought the lesson was, this is what it's almost a demonic, I should use that term, a demonic focus on that. the existential threat that not only comes from the outside world, but within us, because we have a self-destructive existential threat within us. So we care, we focus. We say, you know, you shall not pass, you know, you shall not take us, because we care, we are here, we are alive, we are present, and we can dissolve it. And I think that that's in a sense, but there's something else with that dark force. I realized, just as there's a potential gradient that's 4 billion years up here, and there's this massive PIM interconnected field with this huge Akashic record and everything that we can tap into, and it's a potential gradient. So when Newton rolled a ball down a ramp, it released potential energy that had been put in by taking the ball to the top of the ramp. So there is that is a potential energy gradient, which is represented by probability, not by a physical law, by improbability. But there's something else. There's the opposite. There is the fact that there's a pulling force. Anything that is super complex and up here has a pulling force pulling it back towards equilibrium, pulling it toward dissolution. If you took anything, any living thing from our world and put it on the moon or Mars, you would watch it being pulled apart really fast. That environment does not sustain. That environment will take it apart. In open space, everything gone so quickly, so quickly. And so this force is pulling down on us, but it's a force we can use. It's a two-way, it's almost like a battery of like, whoa, look at how improbable, whoa, look at how far down it is, right? That's a very concentrating force. And I think that is the power we feel. And that through time, as people have tapped into this sort of superpowers, you know, call it God experience, whatever you could call it, when people get taken over by Kundalini flows, things like that, I think it's somehow connected to that, this battery, and that is available to us as a battery, as a plus minus battery. Maybe it's just the opposites, you know, construct and destruct, you know, what we might call evil and good or whatever, but it's all, but maybe that's the super big version of all that. But I think it's put a connector across those two, the up and down, and you get power and force and clarity and energy.
Well, Aya?
There was something you were saying, you mentioned, you're talking about this dark force, and you called it a bugger. And so I was thinking, and you say it's a demonic focus. And I was thinking, what is the difference between a demonic focus and a demonic force? Because like the reaction that you had to this destructive force as part of the universe was a negative one, right? To call it a bugger.
Mm-hmm.
And so the idea is this is not supposed to happen. And I was thinking that's something that the human being thinks from our perspective, from our point of view. This is not something that's supposed to happen because this means the end of us, and we don't want the end of us. So is it a focus that we are seeing this as a demonic thing, or is it an actual demonic force that it has its own negative intentions? I don't know if that makes sense.
Yeah, that's a very good question. That's a good question for philosophers.
Well, I think about this in terms of the role of death in the evolution of life. You know, once natural selection gets going, it's creating more complex life forms and novel solutions to environmental problems, but only because of the sacrifice of countless beings that get it wrong, right? And so without that selection, meaning paying the ultimate price, death, life doesn't evolve, life doesn't adapt, and doesn't complexify. So the little bugger, in providing the degradation, the breakdown, the failure, the dissolution of complex organic forms that didn't solve the problem, it makes room for the organisms that did perform the experiment right and found the solution that allows them to survive in the changing environment. So we need death, we need entropy, We need, yeah, it's,
It's kind of like learning from failure in the same way that memory
mhm.
kind of come in. And it's like you have a memory of a failure, so then next
Right.
time.
Right. And as life gets more complex, its memory becomes more intense, more capable of not forgetting what all the beings that have died. And, you know, human beings, we're not the only species that mourns its dead. Many complex mammals, elephants, other primates seem to do this. But it seems like part of the intensification of consciousness as this PIM cycle, you know, brings us to the top of this spire, is that we become more aware of the role of death, and we become more capable of remembering those who have died in the sacrifice. And we found whole religions on the idea of sacrifice, right? This seems to be part of the creative process. You can't do it. You can't have an evolution of life without death. So, you know, we have to pay attention to that little bugger, but we can't get rid of him or it.
Yeah.
Would that be part of negative prehensions from Whitehead? Could you?
Oh God, you want me to explain negative prehension
Well,
at
no, I mean,
9:30?
could you jump for any Whiteheadians? Would that kind of fit into that, or is that just to give it a framework? In the sense of that, the necessary.
I would connect it more to what Whitehead says about perpetual perishing.
Ah, right, very good.
You know, Whitehead has this concept of concrescence, and that the universe is made of these pulsations of energy, which are also experiential. And in each burst of energy, in each, you know, cycle through the wave function or a waveform, there's the birth of a subjective aim, but then it perishes and is inherited by the next moment, and then perishes. And so there's a life-death cycling that, as you ramp up the evolutionary, you know, chain of complexity, becomes slightly more stretched, so that there's more subjective experience, more capacity to consider possibilities, and then make decisions that are more and more improbable. But it's the perpetual perishing that is, I think, more related to the importance of death in the evolutionary process. So I'm a Whiteheadian, right? I think in terms of Whitehead, I love to see Bruce. He has these two hats. He calls it gearhead and Buddha head. I have Whitehead. So for those of you that have read any Whitehead, maybe what I just said will make some sense. Otherwise, it's just philosobabble.
And last night, Annette brought forth the Yoruba idea of the good head.
Right. Oh yeah, the good head.
The good head, the gear head, the white head, and the Buddha head.
Yes. Yes.
Nice.
Watch the recording to get what Carolyn's talking about. Do you have a question, Matt?
Yeah.
We should try to probably
Sure.
wrap up.
Yeah, so as a former banana snug slug, I appreciate it coming out of Santa Cruz. But I guess, especially as, you know, Fox News calls Santa Cruz the worst school in America. So, but anyway,
It's a
I
badge
was
of honor.
wondering, based on that kind of, and I really appreciated your sort of picture, the graphic of sort of all of the domains that this theory could sort of impress upon or influence. And so I guess I was just curious, because you mentioned economics being a place where it could benefit from some of the ideas that you're sort of bringing forth. I'm curious, or I guess I would invite you both to sort of speculate on what maybe the next 5 or 50 years, you know, would look like in terms of how economics could develop if it were to integrate some of the theories or, you know, you sort of mentioned it before, but I thought you'd do it again.
It's almost as if, say, this plastic bottle crisis. So the plastic bottle crisis is like untenable. So now various cities are banning them, or plastic bags or things like this. It's almost as though if you gamified the whole thing, and like they're trying to do with carbon credits, and you assigned sort of a survival value quotient to plastic bottles appearing in the system, but they go into the entire world system, and you rethought that whole thing. And so somebody invents a plastic bottle made out of potato starch, which I know people have, but it's not economic yet. So how do you gamify that so that potato starch bottles, which actually degrade, become economically viable? And you do it in a little market first until they pop. Because once the plastic starch bottles become economically viable, they will eat the rest of the plastic bottles. And we saw that with organic food, right? Organic food was a very specialty item, was for weird people in little funny stores where stuff fell off the shelves and hippies, and there were no expiration dates. And, you know, you could get manna cakes, you know, that was the original hippie food. But it became a huge thing, and it ate agriculture to a large extent in terms of the profitable part of agribusiness got consumed by this new force because of what people wanted. It was higher quality, et cetera, even though it cost more. It didn't seem to make sense economically. So there is actually ways to do this and that come through the system that will heal and anneal it into new forms. And we've seen it over and over and over again. Electric bikes in cities. Shanghai, they just said, you know what, it is untenable that there has been no blue sky for a year in Shanghai. So the local city government said, Chinese people like bikes and they hate sitting in cars. So they made 2, 3, 4 million bikes, invented the whole unlock system with the phone, created an entire workforce around picking up bikes at night and fixing them and moving them from A to B. And now everywhere you go in Shanghai, there's Chinese are back on bikes. And even out in the office parks where I was last year, they come off the train and there's bikes for them to go to their office. So the number of cars plummeted and there's blue skies in Shanghai. They did it. They did it and people are much more satisfied. They feel better. And the car thing was just untenable. And so then now cities copy that, just like genetic code. They're copying it all over the world. And so if we think in that way, and I think millennials do think in that way more than we old people, you know, we think, oh, it's all going to come through Safeway and it's something we can't affect and we can't change. But millennials and iGens are like, no, it can just be another app, you know, and they reinvented it and it happens quickly.
Yeah. I mean, I think about, you know, thinking about your PIM cycle and the interconnection and the sharing of genetic material and these progenote gels and the mythic significance of that, because evolutionary biology and capitalism have always been exchanging metaphors. Think about Dawkins' selfish gene. It's an idea of what life is. It's just genes trying to make copies of themselves, right? Capitalism is like money just trying to make copies of itself. And we think that the value is in the money. And the more money we have, the better everything will be. The more money individuals have, the better everything will be. I think if we can find ways, you know, based on a new understanding of what life is, a few little tweaks to how we understand money and how we use money can preserve the creativity of markets, but prevent the blood clots of billionaires so that the money circulates. Money is not a store of value, it's a means of communication. Value is in our social relationships, right? So I think just a few little tweaks here in how we conceive of money and how it works can change the game really quickly. But it starts at the level of, I think, it's science, but it's myth. It's our value system. And the way we understand what life is translates into what we value. This was like what I said at the beginning with Whitehead, as we think we live. So I'm optimistic about that. And I think this change is happening already.
Here's a new thought, that because of the mycelial network of economics and communication and information, it's become so freaking dense that you cannot, the system's becoming like a forest. The human economic global system's becoming, it's acting like an ecosystem more and more than before, when things could crystallize into media empire over here and oil and gas empire over here and just get sort of stagnated around nation states, right? Nation states may be dissolving because what relevance is a national government that can't pass legislation and has a screaming idiot? It doesn't have any relevance. So what happens is the power is no longer there. It's all distributed. States are doing it and local, and the power is coming through our hands to each other. So central governments become less and less relevant, and they kind of dissolve and go away, and they're replaced by this other system. And because it's more biological, every moment, every second of the day, it's becoming more and more like a living thing. It's going to start acting like a living thing. And so the dynamism, the increasing dynamism, the rapidity of the change can also sweep out toxic stuff, make change super rapid, like student loan debt, horrible situation. Everyone sees it. It's a huge block for a lot of things. Something is going to come and dissolve that block and shove it out so the system can go forward. It is not an eternal thing because the system is becoming self-aware and the system is becoming intelligent. The more people that come into the system are becoming self-aware about it. So some billionaire goes to all the colleges and universities and creates a credit default swap, buys all the freaking student debt. It could happen. I mean, basically, Jeff Bezos could do that, just one thing, and decides to flip the system and hire all those students. Who knows? But some dynamic thing will come to remove that obstacle. And as it has in the last 30 or 40 years, nuclear Armageddon got removed. That is amazing. Poverty is getting removed as an obstacle. Illiteracy is getting removed super rapidly all over the planet. Women's empowerment in economics. The health of women and the health of infants, which was a huge impediment to progress, is getting swept away super fast. So all these impediments are getting swept away by the living being that is us, interconnected and self-aware. So I think, in a sense, to help us speed that process and help focus attention on student debt, that is not acceptable. And so Germany forgives it or something. Other countries start forgiving it.
They don't charge for education.
They don't charge for education. It's unacceptable. So the United States, the economy starts getting crippled by this and realizing we need to import German students to do jobs because all of our people are working at Quiznos because all they're doing is servicing our debt. This is not going to mean we have a country. We have to just sweep that away if we're going to survive as a country. And maybe that would happen because the US is going to get out competed having this ridiculous system. So it's like trusting the power of evolution, the power of cycles and the dynamism, but also being smart about it and pointing and paying attention to the things we need to dissolve and change.
Yes. One more.
One real quick thing, I just was wondering if you could connect everything you said about decentralization with blockchain and AI. It's real quick.
Well, blockchain's really interesting because for a period of time, I mean, crypto was sort of going to do this, but it got gamed, right? So the challenge you've got is you invent cryptocurrency and all these characters come in and they game it. And they game it into extinction, right? Which is what happened to mortgage debt. They almost destroyed the financial system because, so the gamers come in, they're a toxic force. And that's what they've done to cryptocurrency, the great vision of cryptocurrency. So then we realize we can't just have an unregulated security that anyone can print. It's like, this is a dumb idea. Oh, fiat currencies were actually valuable. It took 500 years to develop a trustable currency up until the 1870s in this country, till they had a central bank. That actually matters. So how do then we marry the regulatory framework and the trustability of the fiat currency system into blockchain to create a really truly powerful global currency that is intelligent? It's not just from some kind of visionary hope, because we realize we're competing with gamers and people who are going to come in and manipulate. We have to regulate. So then the next round of crypto is actually really potent because we learned. So that could be one thing. And AI, we're trying to get AI better. AI is not anywhere near the visions that Hollywood portrays. It's extremely difficult to train and work. I was at a big conference in Oslo recently on AI, and all the people in the labs and governments complaining about the public thinks it's so easy, but it's like we're the DOS era of AI. AI is just a bunch of database searches that have gotten fast enough that it does these neat tricks, but the systems are brittle and fragile, and they're not something to worry about. But there is something to worry about, which is algorithms. More than AI. I mean, AI is just it's just a big database part of it. Algorithms that break our economy, algorithms that run away, and where the system's so complicated that nobody knows what's going on. Like these flash crashes that happen in the markets, we have to be concerned about that. Now, this happened in the telephone networks of the 1930s and 40s, where the system would be on the fritz when they were trying to automate it. So it wasn't Lucille Ball plugging people in anymore. They automated that. And then for a while, it was really unstable. And the phone system kind of was like, we don't know what's happening. But we nailed it. Over time, we nail it. But we have to be careful about who's on the lever of algorithms, especially in politics, which we've just found out. Algorithms are power. Lawrence Lessig was right. Code is the law of cyberspace. And if we live in cyberspace, code is our new law. It governs our lives. Now we're awake to that. So we put our intelligence into it. We need to regulate it. We need to be smart about it. We need to watch who's pulling the lever of algorithms and say algorithms are our future, and they can be the sword that we fall on. So we wake up to algorithms.
And we hire a philosopher.
So how great a threat do you think, and a friend texted me the other day this article on limbic capitalism and the idea of using marketing to promote addiction in consumers on a whole host of things other than alcohol and tobacco.
It's been done for 300 years, yeah.
Yeah, I know, it's been in process, but it's getting perfected.
The whole opioid crisis was,
yeah.
And that's where not just as early philosophers, but good lawyers come in, right? There's liability associated with, say, the opioid epidemic, like as there was with cigarette smoking, advertising, stuff like that.
Yeah.
So our legal system can become an immune system.
Well, I think we're at time. We could keep talking for a billion years, I'm sure. But let's pop this vesicle and go seed other universes.